All right, I think I'll kick us off and I will close this poll and I'll share results with everyone. So it seems like the majority of people who are joining us today are part of the platform team, followed by development and then other. So thank you everyone for participating. My name is Jairo Camacho. I'm part of the Consul product marketing team here at HashiCorp. Today, I'm going to be joined by Paul Glass, Chris Tain from the engineering team, and Usha Kadali from the product management team. And we're all really excited to be here today to share how y'all can securely modernize application development using Consul on ECS. So on today's agenda, we'll start off by breaking down what is service networking, outline why organizations have chosen to deploy Consul as their service mesh on ECS, learn about the benefits of incorporating zero trust principles with Consul, and then pass it along to Chris and Paul to see today's demo. So when we mention service networking, what exactly are we referring to? So we view service networking as being comprised of 4 distinct pillars. The first one is discover, enabling teams to know the availability and health of all services at all times. The second is secure, safeguarding communications through encryption and mutual authorization and authentication. The third is automate, accelerating application delivery through making new services available and scalable without operator intervention. And the fourth is access, controlling the flow of north-south traffic into and out of the mesh. Consul is able to address these core service networking functions at enterprise scale with features such as network infrastructure automation and API gateway, to name a few. So for customers who have chosen to run Consul as their service mesh on AWS, they've done so for the following reasons. The first one being zero trust security. So cloud adoption expands the attack surface for many organizations. And that's part of the reason why we hear this term zero trust being thrown around so much recently. Consul provides a strong foundation for zero trust networking by mutually authenticating, authorizing, and encrypting communications. The second is application resiliency. So Consul ensures services are available whenever your customers need them with configuration entries. It can be leveraged to configure the behavior of proxies to retry requests, timeout after a certain period, and circuit break non-responsive services in order to increase reliability of the microservice infrastructure without having to make changes to the underlying services. And finally, connecting cloud to ground. So through mesh gateways, Consul can actually route database connectivity, whether it resides on AWS, another cloud, or on premises. So let's take this opportunity to evaluate a typical cluster on ECS. We can see here that it's populated with 2 microservice applications, our client service and our service service. An ALB is sitting outside the cluster to regulate the flow of traffic, and another is inside to help with functions such as API calls. Now, this diagram represents a relatively standard way of running things on ECS. But on this slide, we can see that Consul has been deployed as a service mesh. The Consul server is actually running using HCP Consul, our managed offering. Customers are also able to utilize our self-managed Consul with EC2 VMs. On each microservice application, there is now a Consul client along with an Envoy proxy sidecar. And opposed to the previous slide, you might notice that there aren't any load balancers being depicted. And that's actually because the sidecars are able to manage communications between services while the clients are able to control things. Additionally, there is an ACL controller to provision Consul ACL tokens in order for tasks to be able to register themselves with the Consul client. Now we're going to pivot and dive into how Consul can accelerate the adoption of zero trust networking for your organization. First off, when we say zero trust, what exactly do we mean? To distill it down to its simplest terms, it's trusting nothing, authenticating and authorizing everything. This is accomplished by securing everything based on trusted identities. In the past, security was managed by IPs, which doesn't scale in today's fast-paced reality where ephemeral environments in the cloud are being spun up and deactivated in a matter of clicks. Consul is able to tie all underlying IP changes to a service identity to help teams secure communication. So an important pillar of zero trust networking for Consul are ACL controls. Operators can create and enforce policies for users and services with tokens. These tokens contain rules which provide specific privileges and can be combined to create policies. It's really important to issue granular policy definitions when creating tokens in order to provide the least privileges possible for users and services to complete their objectives. Another important pillar is TLS/MTLS. When a new service is created, it needs a certificate to establish TLS communications using the Envoy sidecars. In order to establish and accept connections to and from other services, an MTLS connection is required and is accomplished through the client service verifying the destination service certificate against the public CA bundle. Once the connection handshake succeeds, communications are encrypted and authorized. And we recently announced our support of administrative partitions or admin partitions. It's one of our enterprise-only features that enables organizations to achieve multi-tenancy with minimal operator overhead. In the context of zero trust, it helps organizations safeguard the network by creating isolated environments for teams. The ability to achieve this level of granular network separation reduces the blast radius by limiting what others are able to see and do, while again, providing the least amount of trust required for them to get their jobs done. Now, this concludes my portion of the webinar. I'm going to be passing along to Chris and Paul so we can learn more about that demo. Thank you.
Yeah, thanks, Ira. Share my screen. Okay, so my name is Chris Thane. I'm a software engineer on the Consul ECS team, along with Paul Glass. And today we're going to walk through a demo, some of the topics that we covered in today's presentation using our HashiCorp's demo application. So we've divided the demo into two different personas to highlight a separation of duties that might exist within an organization. These aren't necessarily prescriptive boundaries, they're just an example that we've used for this demo. So I'm taking on the role of the platform team, an admin that's responsible for provisioning and managing our infrastructure resources, including Consul and our Amazon Elastic Kubernetes service and Elastic Container Service clusters, so EKS and ECS respectively. And Paul's taking on the role of a software engineer team member, and he's going to be responsible for deploying the applications within our ECS cluster. So HashiCorp is a demo application that we use at HashiCorp. It allows users to browse and order different flavors of coffee, and each coffee is affectionately named based on our HashiCorp products. So it's a microservices-based application, and it's composed of front-end services and back-end services. And in our case, it's going to be deployed across an EKS cluster and also an ECS cluster. And the services within the application are all part of the Consul service mesh, and that's going to be managed by Consul servers running in the HashiCorp cloud platform. So as Jairo said, HCP provides Consul clusters as a service, and those are fully managed by HashiCorp. So in our demo scenario, we have an engineering team, and they're going to be developing and deploying two HashiCorp services within an ECS cluster. So Paul's going to deploy the public API and the front-end services into ECS. And rather than having the HashiCorp's application fully run on both EKS and ECS, we're going to use the service mesh capabilities provided by Consul to allow the services that are running in ECS to access the existing services running in EKS. So as the platform administrator, I've provisioned and configured all of our infrastructure using Terraform, and we'll examine some of the key aspects of our setup. So we'll start with the Consul UI. So I'm going to log in. When we land on the Consul UI, we end up in the service catalog. So we see that we have our Consul server running. We only have one console server running, so we're in development mode. In a production environment, you would want 3 or 5 console server ability. Have an EKS development partition. So if we look at the services within ECS dev, we don't have any services, and that's expected because we haven't deployed them yet. If we look at the EKS dev partition, we'll see that we have our HashiCorp services running. They're all registered within the service mesh, and they're all healthy. You have green check marks for all of them. So if I click on this front end service, I can go into the instances and see that my front end service instance is running and all the health checks are passing. So along with the admin partitions, which allow us to create the administrative boundaries between our services, we're going to use intentions to control the communication of our applications within the mesh. So we can use intentions to permit or deny traffic between certain services. And the recommended configuration and the way that we have it set up for today is by default to deny traffic between services. So unless we create an explicit intention allowing traffic between services, the services won't be able to communicate with each other. So if we go into the intentions within the EKS dev partition, we can see all our intentions set up. This is just the intentions that are necessary to allow the HashiCorp application to operate. And in the top, we have the public API within the ECS dev partition. We have set up intentions here to allow that service to access the payments and the product API in the EKS dev partition. And then if we look at the intentions in the ECS dev partition, we have the front end in the ECS dev allowed to talk to the public API in ECS dev. And then we have the same intentions showing up here that we had in the EKS dev partition that show us that this ECS service is allowed to talk to 2 of the EKS services as well. Okay, so that's our console setup. And then if we look at our Amazon ECS cluster, we can see that we have just the ACL controller running. And so as Jairo mentioned, so the ACL controller is a component that we provide, and it automatically manages all the ACL policies and tokens for the services within the console service mesh. So it monitors, it sits in the ECS cluster and it monitors all the tasks that are starting and stopping, and it automatically provisions tokens for new tasks as they come on to the cluster. And then any tasks that are stopped, it'll remove the tokens for those tasks. We also need to share some information within all of the components within our cluster, and we use Secrets Manager for that. So we have a few secrets here. We have the gossip key, which is used to ensure that all cluster gossip is encrypted. The bootstrap token is used by the ACL controller to manage ACL tokens. So it provisions tokens for tasks. The console CA cert is used to enforce mutual TLS authenticity within the cluster. And then the console client token is used by all of the console clients within the tasks running on the cluster in order to register within the service mesh. So those are all the key infrastructure bits that need to be in place for us to enable the cross-cluster and cross-admin partition service mesh communication. And I'm going to pass it over to Paul to demo the service deployment to our ECS cluster.
All right. Thank you, Chris. I'm sharing my screen. All right. So as Chris kind of presented, he's already set up the sort of console server cluster. He's set up the ECS cluster and the ACL controller within that cluster to manage secrets for services we want to run in ACS. And now what I want to do is deploy a couple of services on the service mesh and I want to run them in ECS. So the two services I want to run are the front end, this front end application and this public API application. We'll run each of those in their own ECS task. And for console service mesh, there are a couple of additional containers that will run in the task as well. So the first one is the console client, and the other one is this Envoy proxy, and these run as sidecar containers in that same task. The console client will join the console cluster when the task starts up. This sort of enables the task to get sort of service catalog information from console. And the console client also is responsible for configuring the sidecar proxy with the information it needs. So that includes things like the TLS certs for mutual TLS, the IP addresses like locations of other services on the mesh. And this is a console client maintains like a dynamic connection with the proxy over XDS. So like as new information comes and leaves the console cluster, this client is responsible for keeping this proxy up to date with the rest of the cluster. The sidecar proxy is essentially what sort of implements all your service mesh features. So when we talk about mutual TLS or like traffic management rules or other things you can do with the service mesh like metrics and tracing and things like that. Envoy is really the one that implements this. This is your data plane. And the way this sort of works is your front end application, when it wants to make requests to, say, in this example, to public API, the front end will make those requests through the proxy. One proxy talks to another proxy, and those requests make it to that destination service. So that since all requests in the mesh are kind of proxied through these sidecars, the proxy can implement, all these additional features. So it'll enforce mutual TLS for all requests in the mesh, and any other sort of configuration that you have in console. Like if you want to, you can configure traffic management rules to direct traffic to different sort of groups of instances for things like blue-green deploys or like canary deployments or things like that. And if you want to, like Envoy can expose metrics and like tracing information for some application observability. And you kind of get all of these service mesh features without having to modify the application container at all. So the other little detail in this example is we do have an ALB and we use that for ingress to the front end container, just so we can see the UI. We have the front end running on a private subnet, and the ALB gives us ingress to that. So with that, I will switch over to my terminal. Sorry, actually first I'll just kind of show that I have, like what Chris showed, I have this cluster. I just have the ACL controller running. This is my ECS cluster, so there's no other services running here. And in here, in my console UI, this is the default partition, and we're going to run these services in the ECS dev partition. So when we're done with this, we should see a couple of services here registered into the service catalog. So now I'll switch over to my terminal and get these Zoom controls out of the way. What I'm going to do is I'm going to start a Terraform apply. So I've got Terraform, sorry. While that's running, I'll kind of show you some Terraform. So we have Terraform to kind of set up this whole demo. We'll share the links, a link to this afterwards so that you can kind of explore it yourself. What I want to kind of highlight is just some of the configuration for this service So like if you're a service team and you're using Terraform to deploy on ECS, we have some nice Terraform, like a nice Terraform module to make it super easy to deploy service mesh applications on ECS. So we have this first thing is the ECS service. So this is, if you're not familiar with ECS, this is sort of a service scheduler. You give it a task definition on line 21. That task definition is created down below. And we're going to run one container. So the service scheduler could run, ensure that a certain number of containers are running. In this demo, we're just going to run one. And we've got our load balancer configuration, so we can get to the application. Down here, as I scroll down on line 37, we're using this mesh task module. And this is a HashiCorp sort of provided module that makes it easy to create a task definition for use with like Consul and ECS. What this mesh task module does is you give it all these Consul options, and then you provide your application container. So on line 48, you've got this list of container definitions. These are the application containers that you want to run. In this case, I've got just the one container, and it's going to run this public API image. I've got a little bit of configuration. You'll notice that I've set these environment variables to local ports. So like when this, when this public API application wants to access the payment API, it's going to do so on this local port, so localhost 9090. And we'll see that the sidecar proxy is actually going to listen on this port and proxy requests that it receives on that port to the payment API. And so same thing for the product API. We've got a different port, and when it wants to access the product API, it'll do so on this localhost port. And this is sort of all the configuration I need to support the service mesh. I don't have to make any other like changes to the application to like enable the service mesh features. I don't have to include libraries or anything like that in my application. All the service mesh features are kind of implemented in the sidecar proxy. The final thing I give it are this upstream information. Well, maybe not the final thing, but the next thing I give it. So we need to tell Consul like what upstream services this public API is going to access. One of them is product API, the other is payments API, and both of these in this case are running in the EKS dev partition. And this is sort of the only configuration we need to tell it to route requests to those service names in that partition. We're using a default namespace in both cases, and these are those local bind ports. So this instructs sort of the proxy to listen on this local port. So this is how you kind of control on line 56. You control what port your application needs to talk to reach the service through the proxy. And then finally, down below, we have some of the additional config. So this retry join string indicates the location of our Consul server cluster. These two secret ARNs are the Consul server CASR and the GOSP encryption key. These are two secrets that Chris, like my sort of platform owner, had already set up for me. And the Consul client token, this is also set up for me. This is actually created by the ACL controller, so it'll be automatically created. And there's one additional secret here that we don't have to explicitly reference, and that is it's sort of handled by the Terraform modules, but there's an additional token we need that gives us the service or the permissions to register a service into the Consul service catalog. So the two tokens involved are the client token, which is for the Consul client that enables the client to join the cluster, and then the service permissions enable the registration into the service catalog for this particular service name. So I think that's it. So without further ado, my Terraform apply is done. I'm not gonna redo that whole output. I'm gonna switch back over to my UI. So we see these two, this front end and public API have registered. In ECS, if I refresh, we've got the two services. We've got tasks started for those services, and I'm just going to dive into one of these and just show you that we have the containers that would be running. So we have the sort of application, which is public API in this case. We've got the sidecar proxy, which is the Envoy proxy. We've got the console client. So those two things I kind of explained. And then we have this one additional component, and you see that it stopped. So this runs, this mesh init container runs at startup, and it's responsible for registering the service into console. So without this, your task wouldn't automatically join or your service wouldn't automatically register. But with this, you can sort of dynamically spin up ECS tasks. They'll self-register into console, and it makes it super easy to use console with ECS. So finally, I'll kind of show just what you see in the console UI. So we've got my public API service. This is one instance of the service. I could have more than one instance, and they would all be associated with the same service name. It has health checks, and it has these two upstreams, payments, and which is it's accessing an EKS dev, and product API, which is accessing an EKS dev. And then, finally, I guess the other thing is I need to kind of prove that it worked. So here's the application. We're accessing it through an ALB. So that ALB is associated with this front end container. So we've got the load balancing configuration there. So you can still use ECS in sort of the way it's meant to be used with load balancers and things like that, and the ECS service schedulers and such. And then here's our sort of demo app. And we've got our different like HashiCorp themed coffees that you can buy. And I think that's it. I think that's it for the demo. So I'll continue sharing, and Usha will pick it up with the roadmap.
Thank you, Paul and Chris, for the demo. Before we go to the roadmap, a quick poll here. We can end the poll now and share the results. Just quickly reading the results back. It's great. Yes, service mesh will address all of these: security, service networking, and developer productivity. We're all thinking in the right line. All right, coming to the roadmap itself. So what has it been for Consul on ECS as a journey? So last November, we GA'd with a single secure service mesh, single data center secure service mesh. And since then, we added support for multi-data center secure service mesh, and also supporting servers on HCP as well. HCP is our HashiCorp cloud platform, where we host the Consul servers on AWS, or there is an option for running the servers on AWS EC2 VMs. Those are the two choices. And today in the demo, we have seen ECS Fargate tasks, but ECS EC2 tasks are supported as well. And all of this is enabled through our Terraform integration. And not to mention, with our AWS partnership, we do have CDK support as well. And the last two features, namespaces, which was demoed, namespace and admin partitions, which was demoed today, are our two enterprise features that we added support in the last release. And what's coming up in June is first-class support for mesh gateways on ECS itself. Today, if you have two ECS clusters, the mesh gateways have to be deployed in EC2 instance. So instead, the user can actually deploy mesh gateways on ECS itself. Again, there will be a Terraform module associated with this for ease of use. And also in the demo, you have noticed that there is a client and service token to register your service. So instead of using the ITIL token that you fetch from the console servers, we are integrating with AWS IAM auth method. So the developer, again, if you have to separate the developer and the platform owner persona, the developer at the time of the registration would have to specify the IAM role, and it actually verifies with whatever has been configured by the admin to allow certain IAM roles. And if it matches, then the service gets authenticated and it gets registered and it's all good to go. So that would be coming up in June. So with IAM auth method, you don't have to, the end user doesn't have to worry about the client and service tokens. So two less tokens to worry about. And in the future, we would like to hear your feedback to see what kind of support you would really like. And there is a form you can share your feedback. And besides that, we are looking at adding support for API gateway and other console gateways that we support, like ingress and terminating gateway, as again, first-class support on ECS itself. And also, just like improving deployments with IAM auth method, we are looking at different ways to have simplified deployments. And the last one is Vault integration for Secrets Manager. Again, I want to call out Vault integration is done as Connect CA, but today the secrets are stored, let's say the gossip encryption key and the tokens, they are stored in AWS Secret Manager. And in the future, we are looking towards adding that secret managed support as Vault being the secret manager. So this is what we have in our future in the roadmap. And the next slide, please. Yeah, and here is our broad ecosystem integration. And again, as you all know, Consul is a tool that supports any runtime or platform your company is using. And if we look at the different runtimes that we support, there is Kubernetes, Nomad, ECS, and whatnot. And also it can be run on different cloud platforms. We are cloud agnostic in that sense. And beyond the runtime and the platform support, you will see on the top, we do have integrations with different observability products, Datadog, Prometheus, Splunk, and you can actually integrate your observability products using our existing modules, or you can actually hook up your own integrations as well. And we do have other layer 7 integrations, Envoy being one, but also there is Nginx and HA proxy. And if you go down to the bottom of the image, this is very specific to our network infrastructure automation. So when you have your service mesh up and running, let's say there is a need for updating a specific firewalling rule, or let's say a different load balancer. So we do have modules which we call CTS, Consul Terraform Sync modules, as part of our network infrastructure integration effort. So wherein we have integrations with Palo Alto, FI, these are just a few that's mentioned here, but on our website, you will see a whole slew of our partner integrations as well. So wherein you can use these integrations, your automation integrations. So that's it for the demo as such, and we will share all of these links. We understand you wouldn't be able to click it for reference in the future. We will share all these different links, the docs, the GitHub repo has already been shared. That and also there is a learn guide wherein you can actually follow the exact steps to recreate the admin partition. Again, this demo that you've seen today focuses on EKS and also ECS, but the demo that if your environment is only using ECS, the learn guide that we will share actually sets up 2 ECS clusters and how you could actually use admin partitions for 2 ECS clusters or more. We have enough time for questions. Happy to take on questions from the audience. If not, probably I could ask a couple questions, and thank you all for taking your time and joining our Console on ECS Secure Service Mesh webinar. And the first question I was thinking was regarding observability. How this would go to Chris and Paul. How can the team enable observability metrics product into console for, let's say, like, does the admin have to do it, or would the service owner have to do these integrations, and how is the split being done there?
Yeah, if I recall, there is so like, for example, you can set up an integration with Prometheus for like application metrics, and then you can kind of ship some of the Envoy metrics into Prometheus. So you'd and display those in the console UI. So there's some server-side configuration to specify sort of the location of your Prometheus server cluster. And then I believe there is centralized configuration that sort of, I think it applies to all proxies. I can't recall, but there's some centralized configuration you can add to console to enable the metric shipping.
And thanks, Paul. And how about debugging, troubleshooting, if you want to just give some highlights into that, and how easy does it do we make for troubleshooting?
Yeah, so at least for ECS, you have kind of all the typical ways that you debug something on ECS. So there's, you can configure CloudWatch logs to see logs for your containers. You can use execute command. There's an execute command function, which kind of lets you get a shell into your container to kind of see what's going on, run some commands there if you need to debug things starting up. And there are like Envoy debug logs and things like that. Another thing you can set up is like application tracing to sort of get insight into what's going on in your applications, but that's sort of after you've kind of got an application sort of successfully running in ECS. Yeah, I don't know if Chris, you had any thoughts to add there, but that's what I'd say.
Yeah, no, I think that covers it.
And also, any thoughts on migrating services from and to ECS, between ECS and EKS, or on-prem?
Right. So yeah, it's a big question, and it sort of depends where you're starting. If you have not yet set up Consul, then it's sort of up to you if you want to kind of move your services over to the new platform first and then kind of adopt service mesh, or if you want to adopt service mesh first and then move your applications over. I think once you have kind of Consul service mesh set up, it becomes kind of super easy to move things from one sort of platform to another, because Consul will sort of mostly take care of like the routing rules and things for you. Like you just register your service in the new place. The sort of new IP address of that instance will be associated with the new platform, and the service mesh will kind of route the request for you. So it makes it sort of super easy to move services between like ECS and EKS and things like that.
Essentially, we could also use traffic shifting here too, right? To make it seamless. Like
you can to sort of do like a gradual shift over. There's traffic. You can sort of group service instances by tags and create traffic management rules, like routing sort of rules, based on those sort of groups and based on other parts of the request. So that's another way you can kind of gradually shift services from one platform to another.
Yes, we understand. Yeah, we'll have to caution when we say super easy. But we are improving the product with every release, addressing debuggability and troubleshooting. And also trying to do better with our troubleshooting guide as well. Again, I shared the link for feedback session. If there are any requests that you would like to share with us to better Consul, and also any roadmap things, please feel free to fill out that form. We are happy to set up a time and take it from there. And also for roadmap features, you can actually open the request in our GitHub repo. That's another way. And super appreciative for everyone's time today. Thank you all, and have a great rest of the day and rest of the week.